Hi students, Chapter 5 Lines and Angles Part 3. In Part 3, we are going to see intersecting lines. What is intersecting lines? Two lines L and M intersect if they have a point in common. This common point O is the point of intersection. You see the figure. PQ and RS, two lines intersecting at one common point, that is O. Here O is common point. Now we can see some examples. You see the blackboard stand and a letter Y made up of line segments and the grill door of a window. So you can find out the intersection point. Next we will see transversal. You might have seen a road crossing. Two or more roads or a railway line crossing several other lines. See the figure 5.21. These given an idea of transversal. You see the gate, road crossing. Here you see two roads, another roads cross the two roads. So a line that intersects two or more lines at distinct points is called a transversal. So always you should remember three lines or more lines. Another line crossing the three lines in three different points. There you can find out a transversal line. A line that intersects two or more lines at distinct points is called a transversal. Okay. You see in the figure 5.22 also, P is a transversal to the lines L and M. See the figure 5.22, two lines L and M, and P is crossed the L and M in two distinct points, so that P is called transversal line. Now you see the figure 5.23, the line P is not a transversal, although it cuts two lines L and M. But all the three lines meeting at one common point, that is intersecting point. So here P is not a transversal. Next we will see angles made by a transversal. So in the figure 5.24, you see the lines L and M cut by transversal P. The 8 angles marked 1 to 8 have their special names. So you can find out 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. Clear? Here you can find out interior angles. You see the tabular column. Interior angles are 3, 4, 5, 6. That is inside the lines. 3, 4, 5, 6. Okay, easily you can observe these 4 angles are inside the line, so that it is called interior angles. Next you come to exterior angles, 1, 2, 7, 8. These 4 angles are called exterior angles, that is outside of L and M. So it is called exterior angles. Now pair of corresponding angles. You can find out 4 pairs of corresponding angles. You see 1 and 5, then 5, 1 and 5, 2, 6, 3, 7, 4, 8 are 4 pairs of corresponding angles. You might have studied in 6th class also, just to recall it. Now pairs of alternate interior angles. alternate interior angles. You can find out here 3, 6 and 4, 5 or alternate interior angle. Just what 3 and 6 you see, that is alternate. 4 and 5 also alternate. Okay, 3 is in one side of the transversal, 6 is what another side of the transversal, so it is called alternate interior angle. Okay, 3, 4, 5, 6 are interior angles, so it is called alternate interior angles. Now pair of alternate exterior angles, same way you see outside 1, 8 and 2, 7 are alternate exterior angles. Now pair of angles on the same side of transversal. You see the pair of angles on the same side of the transversal, that is 3 and 5 same side. Okay, then 4 and 6 also same side. That's why it is called pair of interior angles on the same side of transversal. Okay. Now you see the corresponding angles like 1 and 5 in the figure 5.25. Okay, include different vertices or on the same side of the transversal or in corresponding position above or below, left or right, relative to two lines. So easily you can find out the corresponding angles. You see 1, 5, 1, 5, okay, on the same side of transversal. Okay, that is corresponding positions. Same way 3, 7, 2, 6 and 4, 8 are the corresponding angles. Next you come to alternate interior angles like 3 and 6. They have different vertices. Are on the opposite side of the transversal and lie between two lines. These are the condition of alternate interior angles. See, you can find out the figure 2.56. You see the figure 5.26. You see the different vertices. 3 is on one vertices, 6 is on another vertices, and they are on opposite side of the transversal, lie between two lines. Okay, same way 4 and 5 also called alternate interior angles. So they are lines on a plane that do not meet anywhere. That is called parallel lines. So the parallel lines, they are lines on a plane that do not meet anywhere. The lines which never cross each other at any point are called non-intersecting lines. These lines are called parallel lines, and the common length between two lines is the distance between parallel lines. You see the figure, two lines, okay, they never intersect. They are called parallel lines. So the distance you see 3, 3, 3, everywhere 3 centimeter distance. Okay, so the common length between two lines is the distance between parallel lines. You see the example of parallel lines, that is best example is railway track. In the railway track you see they never intersect. Clear? It is going on like railway track. Okay. Then ladder stand. You see the parallel, you can find out the parallel lines. Clear? So like this, what you have many examples in day-to-day life. So the transversal of parallel lines, just to recall it, two lines which never meet with each other are called parallel lines. If we have transversal on the parallel lines, then all the pair of corresponding angles are equal. You see, angle 3 equal to angle 7, angle 4 equal to angle 8, angle 1 equal to angle 5, angle 2 equal to angle 6. Always you have to remember, okay, two lines are parallel, then P is transversal line, then you will find out what 8 angles. In these you have to find out the corresponding angles. 1 and 7, 3 and 7, they are equal. 4 and 8, they are equal. 1 and 5, they are equal. 2 and 6, they are equal. Understand? Same way you have all the pair of alternate interior angles are also equal. You see 3, 6 alternate interior angles, they are equal. 4, 5 alternate interior angles, they are equal. In the same way alternate exterior angles also equal. Angle 1 and angle 8, angle 2 equal to angle 7 are equal. Now the two interior angles which are on the same side of the transversal will always be supplementary. That is same side of transversal. Interior angles on the same side of transversal, that is 3 and 5. Both add means you will get 180 degree. That's why angle 3 plus angle 5 equal to 180 degree. Same way angle 4 plus angle 6 equal to 180 degree. Now you can see very easily remember these results if you can look for relevant shapes. The F shape stands for corresponding angles. You see the shape of the corresponding angles, it will form F. Okay, see the two angles in F. Okay, everywhere you see two angles, the form of F. Same way the Z shape stands for alternate angles. You see alternate angles, you can say the shape Z. Okay, all the three diagrams you see, you will get Z shape means alternate interior angle. So that easily we can find out the corresponding angles and the alternate interior angles. Okay. Now checking for parallel lines. If two lines are parallel, then you know that a transversal gives rise to pair of equal corresponding angles, equal alternate interior angles, and interior angles on the same side of transversal being supplementary. When two lines are given, is there any method to check if they are parallel or not? You need this skill in many life-oriented situations. A draftsman uses a carpenter's square and a straight edge ruler to draw these segments. You see the figure 5.30. You might have seen the carpenter's square. Thus, when a transversal cuts two lines such that pair of corresponding angles are equal, then the lines have to be parallel. You remember, when a transversal cuts two lines such that pair of corresponding angles are equal means then the two lines have to be a parallel lines. Look at the Z. Figure 5.31. The horizontal segments here are parallel. Horizontal segment here parallel because the alternate angles are equal. So when a transversal cuts two lines such that pairs of alternate interior angles are equal, then lines have to be parallel. That is just converse of. Okay, converse of corresponding angles are equal. When the two lines are parallel, you can say converse of alternate interior angles are equal. When the two lines are parallel, then you can say alternate interior angles are equal. Now just to reverse, when the alternate interior angles are equal, then you can say two lines are parallel. Both way it is satisfied. How to remember? Clear? Next you come to 5.32. Draw a line L. Draw a line M perpendicular to L. Again draw a line P such that P is perpendicular to M. Thus P is perpendicular to a perpendicular L. So you can find out P is parallel to L. How? This is because of you draw P such that angle 1 plus angle 2 equal to 180 degree. So when a transversal cut two lines such that pair of interior angles on the same side of transversal are supplementary, means then the lines have to be parallel. Okay, two lines and one transversal line if you have, then angle 1 plus angle 2 equal to 180 degree, means immediately you can say line L is parallel to line P, because interior angles on the same side of transversal. Interior angles on the same side of transversal. Okay, if you take the sum means it is supplementary, that is 180 degree. Understand? So using these concepts, I will give some problems as homework. You do the homework problems for better practice. Okay.